Welcome, ladies and gentlemen, to 22.3, which I've entitled the Multimeter. Here's a picture of the multimeters that we're going to be using in class. The multimeter is one of the most useful tools if you do anything with electricity or electronics. It is the most useful thing you can ever get. My multimeter is what's called auto ranging, meaning I just set it to a certain spot and it will range. It will tell me if it's kilo or mega or micro automatically. It does all that stuff automatically. I don't have to futz with a bunch of levers. It's really good. It measures voltage, current, resistance, and continuity. It does a lot of other things, but these are the four things that we're going to use it for primarily. Now, to measure voltage, I'm going to zoom in on it here. You'll see that when you look at this, there's a dial. To measure voltage, what you're going to do is you're going to set it over here to voltage AC or voltage DC. We're going to be primarily using DC, which is direct current. Any battery is direct current. So anytime your power source is a battery, direct current. Alternating current we will never use, and that's from the wall. And never stick this thing in a wall. You will find yourself unconscious on the floor and maybe dead if you screw that up. I never want you to play with voltage coming out of the wall unless you know what you're doing. To measure current, we're going to be putting it over here on these three sections. We'll put it over here on either microamps, if you're expecting something in the millionths of an amp, milliamps, if you're going to put it over here in the thousandths of the amp. And you'll notice here, see the units? It went from microamps, now it's at milliamps. Or if you're expecting a very large current, you put it over here at 10 amps. And this, you'll notice this one's yellow, and why is it yellow? I'll explain that in a second. Resistance. You're going to put it all the way over here on resistance, and you'll see that there's right now mega ohms are my units. And then lastly, continuity. You'll put it all the way over here to the right, and you'll see this symbol up here. That's not the symbol for continuity. You hit the mode key once, and you'll see how it looks like speakers. That's what you want. And that's where we'll actually start here with continuity. Now, in order to get your meter to work right, you have to plug in what are called leads. I've got a red and a black lead. These are called test leads. And you'll notice that they're color-coded. If you look at the bottom hole here, this is black. It's called the common. The black one always goes there. Let me zoom out so I can kind of show you exactly what I'm doing here. Here's the lead, and the other side of the lead, my red, I'm going to put it over here in the right one. For everything that you're going to do, you're going to keep it over here in the right-hand hole. It goes in the left-hand hole when you're going to use this symbol. You see how the yellow kind of comes along here? If you put it over in 10 amps to measure a large amount of current, then you'd have to pull this one out, put it over here, because it's got a separate fuse. Explain all that in a second. So continuity, the first thing we're going to do, continuity, you hit the mode key once, and it's got that little speaker-like sound up there when you touch this. Here, beeping. That means that you've got an electrical connection. So if you're trying to test if a wire is broken or you've got electricity is able to flow through a certain path, you want to test whether or not that path is good, use continuity. So for continuity, hit the mode key, and you want to have that symbol. The next one, voltage. So what I'm going to do, I'm going to set up a very simple circuit here. My circuit is going to look like this. I'm going to have a 9-volt source. I'm going to have a resistor that is 70 ohms, like this. And I'm actually set that up and build it for you right now. My 9-volt source. If you look at your 9-volt battery, there'll be a minus sign you'll see there, and you'll see on the other side it's got a plus. So I'm going to hook the red one up to the plus. These are called alligator clips or test leads, or alligator leads. Here's my resistor. So I'll hook it up to this guy, and I'll have a black one, And then from the other side of the resistor, it goes to the negative of the battery, like this. And just a reminder that the long one is always the positive, and then the short one is always the negative. So here I've got built, maybe you can see this a little better if I go like this. Here I've got that circuit, and now I'm going to measure the voltage. Now to measure voltage, we're going to set it on voltage direct current. So I have my meter set to voltage direct current. And all I do is touch it. So when you measure voltage, you have to make sure your meter is on voltage direct current, which I've done. You just touch it. You don't have to unhook the circuit because we're trying to measure pressure. The circuit needs to be on and pushing water through the circuit for there to be pressure built up. You have to put the red one on the positive side and the black one on the negative side. So here's my positive. So first of all, let's measure the voltage of the battery. We expect it to be around 9 volts. Let's just see how it is. We'll put the red one on the positive and the black one on the negative. And you'll notice that we have 1.27 volts. My battery's dead. This battery doesn't have enough pressure that it should have. And we expect this to be around 9. Watch what happens if I screw this up. If I put this on the wrong one, I'll get I should just get a negative. Negative 1 point. It should be the exact same number, but it's not for whatever reason. Let's measure the pressure on each side of my resistor. So again, here's my red. I follow the red one around, the positive. I put the red positive, and then my black one goes on here, and I can measure the pressure difference on that resistor. 1.2 volts. If I screw this up and I put it the wrong way, you'll notice I get negative 1.2. And there's nothing wrong with getting a negative. You should always try to get the positive. But getting a negative isn't going to hurt the meter. Doing this wrong isn't going to hurt the meter. So this is called a parallel connection. I've got my circuit here and my resistor, 9 volts, 70 ohms. What I did to measure I hooked my meter up like this. I just touched both sides of the resistor of the resistor. By touching the two sides, I've made that circuit that I've drawn in the schematic up there, 1.1. Current. Current is really dangerous to measure. If you do this wrong, you'll break the meter. And it's got protection built in the form of a fuse. But if you do it wrong, you don't get second tries. You do it wrong, and it blows the fuse. So to measure current, we have to make sure our meter is in the correct setting. We're going to put it over here in milliamps, microamps, or the 10 amp setting. You have to disconnect the circuit. You have to disconnect the circuit, and I'll show you what I mean by that. The red goes on the positive side, and the black goes on the negative side. So I go back to my circuit here, my original little circuit that I've made with my battery, the red to the black. What I'm going to do to measure the current, I have to break the circuit, meaning I disconnect the circuit someplace. And I'm going to put my meter in there. And in order to do that, remember I told you it goes in the red? So here's my positive side of my battery. It goes in the red lead, so I hook this alligator lead to there. And then it comes out the black, so then I can touch this like so, and it will measure how much current is there. I've got 13 milliamps, or 0.013 amps. If I did that wrong, I'll get a negative, and again, it's not bad for the meter. Hook this up the wrong way, I'll get a negative current reading, negative 13. But here's the real danger, and this is where I see students screw this up all the time. You'll notice that when I measure voltage, I put it on volts and then I just touch it. And when I measure current, I put it over here in milliamps and I break the circuit. I open the circuit up, red to red, black on the black side. If you mix that up, you'll fry the meter. Because here's what I did. I've got my resistor, and then I put my meter inside of here like so. This is called a series connection. When you chain things together like a train, into the resistor, out of the resistor, into the meter, out of the meter, this is called series. When you have two pathways, like you'll notice here, the current, the electricity can flow through this way or it can go that way. There's a choice. We call that parallel. If you screw this up, if you take your circuit, my original little circuit here, I set my thing to measure milliamps, but then I touch it. I just touch it like I were going to measure voltage. I break it. I short circuit it. I literally skip around the load. This circuit, what I would do, if I touched this in the amp setting, which is bad, and you get, there's no second chances. Like you just instantaneously touch it, it instantaneously blows the fuse. No second chances. You'll have to take the meter apart, change the fuse. I mean, it's like a 5-minute delay right there, plus the cost of a fuse. What you're doing is, because ammeters, they let the current flow freely through there, the current coming out of here says, why would I go through the resistor when I get a free trip around? So all the current flows this way, and none of it goes through the resistor, effectively shorting your circuit. It shorts around it. Too much current flows. The fuse protects the meter by melting, and there you go. And just like a voltmeter, you don't want any current flowing this way. You don't want current going around the resistor. You want the current to stay in the circuit. So this has tons of resistance. An ammeter has no resistance. They're fundamentally different. One's got tons of resistance, the voltmeter, and the ammeter has almost no resistance. They're fundamentally different, and if you hook them up wrong, the voltmeter you can hook up wrong, not a big deal. It protects itself because it has lots of resistance. The ammeter is the dangerous one. Danger, danger, danger. If you hook up the ammeter incorrectly, it doesn't work. Now let's measure resistance. Back to my original circuit here. If I want to measure the resistance of this, I told you it was 70 ohms. If I wanted to measure the resistance here, what I have to do is disconnect everything. If I want to measure the resistance of my resistor to see what it is, I have to unhook it from the circuit completely. Take away my power source. I set it over here to the resistance setting, and then I use my leads to just touch it. And it says 70.3 ohms. You'll notice that there's no units, no prefix in front of the ohm symbol. It's just 70. If I hook this up backwards, it doesn't make any difference. Resistance one way is resistance the other way. It shouldn't give me a positive or negative. I get 70 again. And you have to make a nice hard connection. That's kind of tricky to do with these round leads. So to measure the resistance, you take the load out of the circuit. You have to disconnect everything. You just touch either side. It doesn't matter which side the red goes on, which side the black goes on. And then you put the meter in the ohms setting. So that's kind of your introduction to the multimeter. It's a fascinating device, works really well.